stop production at that moment, and have somebody work on fixing that build. Now, the good thing about Accurev is that instead of actually bringing production to a halt, you can actually continue to work. You can simply isolate the broken code and let developers continue to check into to a buffer area so that they're still productive while the guilty party is going off and fixing the build that they broke. I sort of stole my own thunder here. The key is that you want to eliminate the work stoppages that typically happen when builds break. You want to make sure that the bulk of the team remains productive and that you don't get caught in the cycle that I think everybody who's in the audience has probably seen this a few times in their career. These massive beginning of project or end of project merges. Fear of branching and fear of merging really go hand in hand. If it's difficult to do these tasks in your tool, if the tool is inhibiting your process, then like most other things in human nature, you're going to tend to avoid the pain. Nobody wants to, well, not nobody perhaps, but most people don't want to deliberately go and do something painful. So people will defer the merge and save up a huge number of merges for the end of the project, when it's absolutely the last minute and we absolutely have to do the merge, otherwise we can't move on. And anybody who's actually done that knows that those merges, depending on the size of your code base, can take anywhere from days to weeks in the extreme cases. So the ability to very easily do branching and merging frequently, as dictated by your process as opposed to as dictated by your tool, is a key to building quality software. I mentioned one more point, which is that all of this put together, when you put together the idea of being able to merge efficiently, being able to create new code lines as you need them, all of this adds up to parallel development. And if you think about Agile, and I'm not sure how many people in the audience are really doing Agile development, but at Accurev, we have a lot of customers that are turning to Agile development. And one of the key features of Agile is that you want to be able to take a particular piece of work at a given stage in its life cycle, send it off to customers for review, get their feedback, all the while having other people working on other features. And at some point, you build up a set of features that you ultimately want to release out to the public as your general availability release. The ability to do parallel development efficiently, including things like being able to do merging and branching, is what I like to call Agile 101. If you can't do that efficiently, if your tool is not letting you do that, then you're going to have a lot of difficulties doing an Agile development process. Finally, it all comes together in continuous integration. I hinted at one particular integration process, the familiar nightly build where you run your regression tests. I think Martin Fowler said it best in that continuous integration is really extending the idea of the nightly build, simply adding more tests and doing it more frequently. One of the key benefits here and why it's such a good practice is that it's automating another practice. So anytime you've identified a good practice like doing frequent merges, integrations, and testing, you've really saved yourself a lot of time and potentially a lot of money. The other key thing is that, and this is often lost on people who are first introduced to continuous integration, again, because they think it's a panacea, it's a silver bullet for all quality issues. What it really does for you is it forces you to run your tests frequently, and therefore you're going to catch defects early in the development cycle. Beyond just forcing you to run your tests frequently, as new code is being introduced, you can do a lot of other clever things in a continuous integration environment. As we'll see with Anuja's presentation later, you can integrate any number of static code analysis tools into your continuous integration process so that not only are you running regression tests on new code or change code, you're also running some very significant analysis to be able to pull important data and important metrics out of your code. Okay, now everybody has to hold tight because here's my one and only animation in my part of the presentation. Here it comes. Okay, I was really excited by that. I like that. So what I show you here is a hierarchy that emulates what a lot of people might do in the continuous integration environment. And I just want to spend a few moments talking about what you're seeing here and how you can model a very sophisticated continuous integration environment. So looking from the right-hand side of the diagram, we see that there's a couple of teams in dark purple, and it looks like they're distributed a little bit across the world. And there's a couple of teams in green. There's a client team in Tampa and a server team in Boston. And then there's another box there that looks like it has third-party code in it. So the idea here is that as you look on the right-hand side of the diagram, you're closer to developers, you're closer to people who are changing the code frequently. At some level, you're closer to instability. That's the place where the code is changing the most. Chances are that's the place where defects are being introduced and the code is least stable. So one of the ways you can improve your process to increase the stability of the code as it gets towards release is as code gets pushed up the hierarchy, for example, the client server and third-party code getting integrated into the little stream that we'll call core int, and the two GUI teams getting things integrated into the UI int streams, you can and should be running continuous integration builds on those streams. Now, the good thing about Acurev, again, without spending too much time on one particular tool, is that the stream hierarchy in Acurev actually makes it very easy to set up this sort of multi-stage continuous integration hierarchy. Once the code passes in the UI int and the core int streams, you can have an automated process that promotes that code to the QA stream, where, for example, it might undergo another round of regression tests to make sure that the integration proper of the UI and the core, in this case, worked. It might undergo some additional system testing, where in addition to testing perhaps on a single platform to make sure that some subset of the regression tests ran, you might test it on multiple platforms to make sure that no platform dependencies have been introduced, for example. And similarly, as that QA stream stabilizes,